Hello everyone, welcome back to the channel. In this video, we're doing a deep dive into Kubernetes, but don't worry, we'll explain everything step by step and in simple terms. By the end of this video, you'll understand what Kubernetes actually is, why it exists, its core components, how applications really run inside a Kubernetes cluster, no prior Kubernetes knowledge needed. Let's get started. Before Kubernetes, applications were usually deployed on physical servers or virtual machines. Then came containers, like Docker. Containers made applications lightweight, portable, easy to run anywhere. But containers created new problems. How do you manage hundreds or thousands of containers? What if a container crashes? How do you scale up during high traffic? How do containers talk to each other? That's where Kubernetes comes in. Right-finger Kubernetes is a container orchestration platform. In simple words, it automatically manages containers for you. Kubernetes, often called K8s, is an open-source system that deploys containers, scales them up or down, restarts them if they fail, helps them communicate, manages infrastructure efficiently. Think of Kubernetes as an operating system for containers. You tell Kubernetes what you want, and it figures out how to make it happen. A Kubernetes setup is called a cluster. A cluster has two main parts: control plane, worker nodes. Control plane. The control plane is the brain of Kubernetes. It decides where containers run, when to restart them, how to scale them. Worker nodes. Worker nodes are where your applications actually run. Each worker node runs containers, Kubernetes components that talk to the control plane. The control plane is responsible for managing the entire cluster. It decides where applications should run, monitors the health of workloads, keeps track of the cluster's state, and ensures everything matches your desired configuration. If a container crashes or a node fails, the control plane detects the issue and takes corrective action automatically. You can think of it as the manager that supervises the entire system. Worker nodes are the machines where your applications actually run. Each node provides computing resources like CPU and memory. They host pods, which contain containers, and communicate continuously with the control plane. The control plane sends instructions, and worker nodes execute them. So while the control plane makes decisions, the worker nodes do the real work. A pod is the smallest deployable unit in Kubernetes. Usually, a pod contains a single container, although it can hold multiple tightly coupled containers. All containers in a pod share the same network and storage resources and have one shared IP address. An important rule to remember is, you never deploy containers directly, you deploy pods. Pods are designed to be temporary and replaceable. Let's do a quick challenge to make sure the concept is clear. Imagine you deployed 3 pods for your application, and suddenly, one pod crashes. What do you think Kubernetes should do? Option A, do nothing. Option B, restart the same pod. Option C, create a new pod automatically. Pause the video for a second and think about it. The correct answer is create a new pod automatically. And that's exactly what ReplicaSets are designed to do, which we'll look at next. ReplicaSets ensure that a specified number of pods are always running. For example, if you want 3 copies of your application, the ReplicaSet makes sure 3 pods exist at all times. If one pod crashes or gets deleted, Kubernetes automatically creates a replacement. This is one of the key mechanisms that provides reliability and high availability. Deployments are the most common way to run applications in Kubernetes. They manage replica sets and provide advanced features like rolling updates and version rollbacks. For example, when you release a new version of your application, Kubernetes updates pods gradually without downtime. If something goes wrong, you can quickly roll back to a previous version. In real production environments, most stateless applications are deployed using deployments. Pods are temporary and can be recreated at any time, which means their IP addresses change frequently. Services solve this problem by providing a stable network endpoint. Instead of communicating with individual pods, applications talk to a service. The service automatically load balances requests across available pods. This abstraction makes networking reliable and predictable. Here's a real-world situation many beginners run into. Imagine your application connects directly to a pod using its IP address. Later, Kubernetes replaces that pod, and the IP changes. Suddenly, users can't connect anymore. So what's the mistake here? Pause for a second and think. The problem is, you should never depend on pod IPs directly. Instead, you use services, which provide a stable network endpoint regardless of pod changes. Now let's see how external traffic reaches your application using Ingress. Now let's look at how users access your application from outside the cluster. Traffic usually follows this path: user right-pointing arrow Ingress, right-pointing arrow service, right-pointing arrow pod. Ingress acts like a smart router. It can direct traffic based on URLs, manage HTTPS, and expose multiple services under one domain. This helps organize and control external access efficiently. Applications require configuration and sensitive information. ConfigMaps store non-sensitive data, like environment settings or feature flags. Secrets store sensitive data, such as passwords, tokens, and certificates. Separating configuration from application code improves security and makes deployments more flexible. One of Kubernetes' most powerful features is automation. Self-healing means that if a pod crashes or a node fails, Kubernetes automatically recreates workloads. Auto-scaling allows Kubernetes to adjust the number of running pods based on traffic or resource usage. This improves reliability while optimizing infrastructure costs. Kubernetes has become an industry standard because it's highly scalable, cloud-agnostic, and reliable. It runs on any major cloud provider and even on-premises infrastructure. Organizations use it to build resilient systems that can grow without manual intervention. From startups to large enterprises, Kubernetes is now a core part of modern infrastructure. Let's quickly recap the key ideas. Pods run containers. Deployments manage pods. Services provide stable networking. And Kubernetes automates scaling, recovery, and management. If you understand these core concepts, you already have a strong foundation in Kubernetes. Thanks for watching, and let me know what topic you want next.